This 6-story structure isn't a factory or a workshop. It is the engine of the world's largest LNG-powered container ship. It is so vast inside that workers can easily walk around within it. This engine drives a propeller that stands as tall as a 2-story house. Naturally, being the engine of a massive container ship, it consumes a tremendous amount of fuel, burning through 100,000 to 200,000 liters just during startup. Astonishingly, its fuel tank is large enough to accommodate 6 Olympic-sized swimming pools holding 20 million liters of liquefied natural gas, LNG. In today's video about global marvels, we explore the construction of a mega project that has truly pushed the boundaries of human engineering. We are in the 21st century, yet 90% of international trade goods are still transported by sea, ranging from tiny items like needles to the largest vehicles. To put this in perspective, flight radar data shows that 15,000 to 20,000 airplanes are in the sky at any given moment. Meanwhile, looking at marine traffic, specifically, at the time this video is being made, an astounding 308,000 cargo ships are currently underway across the globe. Regarding size, humans have already built massive ships. While constructing even larger ones is technically possible, they would be unable to navigate major waterways like the Suez and Panama canals. Consequently, the competition has shifted from building bigger ships to creating vessels that are as fuel efficient as possible. This is precisely the path taken by the French shipping company CMA-CGM, which set out to build the world's largest eco-friendly ship. It runs on LNG, the liquid form of natural gas, rather than diesel or HFO-type fuels. This 400-meter-long vessel is equivalent in length to 4 football fields lined up end to end. It has a width of 61 meters, and its height exceeds that of the Qutb Minar. The ship's total weight is 70,000 tons, equivalent to 7 Eiffel Towers or 11,500 African elephants, and that is without any containers on board. It has a total capacity of 2,312 containers. To grasp its sheer scale, imagine lining these containers up. They would form a continuous row nearly 150 kilometers long. However, the real challenge wasn't just building this massive ship. CMA-CGM had to construct 9 of them within a very tight time frame of just 2 years. A shipyard in Hong Kong, 4 kilometers long and resembling a small city, was selected for the project. Here, 6,000 workers from around the world work around the clock, each assigned specific tasks. But the question remains, how is it possible to build 9 ships in 2 years when constructing a single ship normally takes 18 months? The straightforward answer lies in building the ships in sections known as blocks. The ship's foundation is constructed using steel sheets treated to prevent rust. Building one ship requires 12,660 steel sheets. These sheets are cut using a massive laser beam with a temperature of 18,000 degrees Celsius, 3 times hotter than the surface of the sun. The laser cuts through the steel as easily as a knife slicing through butter. A total of 880 kilometers of steel plating is cut for a single ship. These sheets are then joined together to form the blocks. These blocks can range in size from that of a single room to the height of a multi-story building. Remarkably, pipes, wiring, and other fittings are pre-installed within these blocks. This is the stern, the rear section, of the massive ship, constructed by joining 5 separate blocks together. Weighing 790 tons, it is as heavy as 2 train engines. 2 giant cranes were used just to lift this massive component. Then, through precise calculations and meticulous control, it was positioned onto the ship's pre-existing structure. It is crucial to remember that an error of even a single millimeter could ruin months of hard work in an instant. Once all the blocks are in place, a seemingly endless and astonishing phase of welding begins. Remarkably, a massive ship requires a total of 1,250 kilometers of welding. If laid out in a straight line, the weld seam would stretch nearly 1,200 kilometers. After welding is complete, every joint undergoes rigorous inspection, as the relentless ocean waves show no mercy to even the slightest structural weakness. So far, the story has focused on the construction of the hull and blocks. The real marvel, however, lies in the ship's engine. This vessel will not run on traditional oil or diesel fuel. It is designed to operate on LNG, liquefied natural gas. This represents a major victory for the environment. This is because, compared to oil, LNG emits 99% less sulfur oxide, causes 91% less air pollution, and releases 20% less carbon dioxide. It represents a massive step toward making maritime travel cleaner and more eco-friendly. However, if CMA-CGM wants to bring this revolution to the shipping industry, they have to pay a high price. The biggest challenge here was storing LNG in its liquid form, specifically creating a fuel tank capable of keeping the LNG chilled at a temperature of minus 161 degrees Celsius. If the temperature rises even slightly or the tank's insulation fails, the LNG would turn into gas and disperse, leading to a catastrophe. Furthermore, this massive ship needs to traverse the long sea route from Asia to Europe without refueling. This necessitates an enormous LNG fuel tank. But just how big is it? Surprisingly, it is the largest LNG fuel tank in history with a volume of 18,000 cubic meters. Its interior is so vast that 6 Olympic-sized swimming pools could easily fit inside. In total, it can hold approximately 20 million liters of LNG. Yet the real challenge wasn't just constructing such a massive fuel tank inside the ship, it was protecting it from heat. It is akin to building a giant thermos, equivalent in size to 6 swimming pools within the vessel. It took the company nearly 9 months to build this fuel tank. Successive layers of insulating material were applied to the tank walls to block external heat. Then came the crucial heat leakage test, as it is vital for the tank to be completely airtight. Workers employed a very simple method for this, applying soapy water to the joints, placing a glass container over them, and using a compressor to extract all the air from inside the tank. If any joint is weak, the vacuum causes air to be drawn in from the outside, creating visible bubbles. This method allows for the identification and repair of leaking joints. Once the leak test is complete, the final layer of insulation is applied. This consists of a special membrane made from a thin sheet, only 1.2 meters thick. When the LNG, chilled to minus 161 degrees, comes into contact with this membrane, the steel contracts. Its unique wavy design allows the steel to contract and expand without fracturing. Remarkably, this same technology is also utilized in space stations. After 8 months of rigorous work, this technological marvel, essentially the world's largest thermos, is finally ready. Now, let's look at the engine. It is the largest natural gas-powered engine ever built. Standing 20 meters tall, roughly the height of a 6-story building, this massive engine generates 85,000 horsepower. It is so large that maintenance staff can actually walk around inside it. Transporting the engine to the shipyard was a monumental challenge. It had to be dismantled into 6 separate sections for the journey. Its most critical component is the crankshaft, the shaft that transmits power to the propeller. This single crankshaft weighs approximately 20 tons. A specialized 14-wheeled remote-controlled platform was constructed to transport it, and it was subsequently installed with millimeter-level precision. The engine features 12 pistons, each with a diameter of 1 meter, connected to the crankshaft. It is this engine that drives the propeller located at the stern of the ship. This single-piece cast propeller weighs 92 tons and stands approximately 10 meters, 33 feet tall. Engine power is transmitted to the propeller via a propeller shaft. It is crucial for this shaft to be perfectly straight. Even the slightest misalignment would cause severe vibrations at high RPMs. To verify this, a special blue dye is applied to the shaft before it is fitted into the propeller. Upon removal, the contact marks reveal which parts of the shaft touched the propeller's inner surface. This test indicates to the engineering team where contact was insufficient and where there was excessive pressure, allowing for necessary adjustments. Once the ship's main structure was complete, the focus shifted to protecting it from the marine environment, specifically applying paint to guard against saltwater, massive waves, and constant friction. These elements can gradually corrode the steel and roughen the surface, leading to increased fuel consumption. To address this, a special paint was used. Approximately 1 million liters of paint were applied over a total surface area of 950,000 square meters, an area roughly double that of Vatican City. Finally, the ship's highest and concluding block, the command bridge, was installed. This serves as the ship's brain, the hub from which the captain and crew control the entire vessel. This massive 400-meter-long ship is equipped all around with a state-of-the-art system called Smart Eye. This system allows the captain to view a full 360-degree panorama right from the bridge. Finally, after a year and a half of ceaseless effort, the first ship, Jacques Sade, was ready. Then began a rigorous 15-day sea trial. During this period, every single component of the ship was tested individually. Engine speeds were verified, emergency braking systems were tested, and navigation systems underwent thorough checks. Simultaneously, the entire structure was inspected for any potential leaks. Crucially, the anchor was also deployed and tested. The anchor of this giant beast is so massive that a single link of its chain weighs nearly 300 kilograms, and the total weight of the chain equals that of about 60 African elephants. Ultimately, the ship successfully passed the 15-day sea trial. The engineering team's dream of creating a low-carbon vessel finally became a reality. Racing against time, the shipyard emerged victorious, constructing 9 such container ships in record time. This story is not merely about building a mountain of steel. It is a tale of the talent, sweat, and tireless day and night labor of thousands of workers. This colossal ship is now ready to rule the world's oceans, doing so in a manner far cleaner and more eco-friendly than ever before. These megaships stand as a proof that when humans resolve to achieve something, they can turn even a mountain of steel into reality. That concludes today's video on this global marvel. We hope you enjoyed it. Please leave a comment sharing your thoughts, and if you liked the video, do hit the like button and share it. Subscribe to our channel for more videos like this. Thank you.